Hey, what's up? We're going to be converting this amide into a carboxylic acid. In the previous reaction, we converted a nitrile into an amide. In this reaction, we're converting that amide into our carboxylic acid. I think if you just boil it or you add heat, something happens, it becomes a carboxylic acid. Okay, so right here, we start off, we have an excess of water. If you look right here, we have an excess of water. And so, water itself is not reactive at all, but, and so water and H2SO4 mix hydronium. So this is why we have hydronium formed here. Okay, now that okay, so what we're gonna need to do is we're gonna want somewhere in this reaction, we're gonna want water to attack the carbon. But right now, this is pretty chill, right? But the water isn't gonna attack it. So what we're gonna need to do is first we're gonna have to activate the carbonyl. So we're gonna have oxygen attacking the hydronium. Water is going to be the oxygen is going to be attacking the hydronium. So if we protonate oxygen, well, what happens is we're increasing its electron withdrawing ability, and it makes it a better acceptor of electron density. And so now we formed a delocalized charge, so we could form resonance structures. So push electrons towards the positive charge. So push that pi bond towards it. Uh, and we can form one more resonance structure. Okay. Now we activated the carbonyl. It's now reactive. Okay, so look for the second best resonance structure, or basically the resonance structure that doesn't have all three. It doesn't have four. Whatever thing is not happy. Carbon wants four. It has three bonds. So this is why it's unhappy. So now we can finally have water attack it. So we're gonna have water attacking uh the carbon, right? And so now let's put that on it. Okay, it's gonna attack it. So now we're gonna form this. We're gonna form an oxonium ion. So let's just draw everything out. Okay, so what do we have in excess? We have an oxonium ion. Obviously, a charge on oxygen isn't good, so we're gonna use the thing in excess, which we have in water, to deprotonate it. So acid base right here. So now we should be good. Now we have a neutral molecule. Um, so now we're gonna want to kick out. Now the thing that's next, we're gonna want to end up kicking out the amine. So what's gonna happen is really the same things from the other reactions. We have I mean, nitrogen is less electronegative, so it's more likely to get rid of its electrons. So, but we're gonna want to kick it out either way. So whatever argument you have, they all work. Nitrogen is gonna leave on its own, but right now we're gonna have to make it. Like imagine like we used water, right? We used water. Like you might be asking, like, oh, we have a lot of water in the flask. Why can't nitrogen just attack this and form that, right? It's a good argument, honestly, because I be thinking that too. Like, why is it attacking hydronium? Because we're always talking about what's in excess, right? Let's say it attacked that. What we're gonna form is this. We're gonna form a negative charge. We're in acidic conditions. We cannot form that. Just why we use the hydronium, because we just want to avoid negative charges at all times. We're in acidic conditions. Maybe write this down. Acidic equals no negative anywhere. You should never have a negative charge anywhere. So this is why it attacks the hydronium. And either way, you could also say that hydronium is formed right here. So in this part, hydronium is formed. So whatever it is, now nitrogen is able to leave without without forming that negative charge. So just unimolecular loss right here. And so now we're almost done. We're gonna form a carbocation, a delocalized carbocation. Right here. And so now we do some resonance structures. push electrons towards the positive charge. Just push that there, and we should be good. We're almost done. So which okay, so comparing these two, resonance structures, which one, A or B, which one looks like our answer? I'm gonna go with the one with the double bond. Look at double bond here. There's a double bond here. That one looks like it. So this is the one that the thing we have in excess, which is water, that's gonna deprotonate it. So just draw your water. Oh, that's not clear. Right here. This is the end of the resonance structure. Okay, so water is gonna attack right here. And so now we're gonna form our carboxylic acid. And make sure you regenerate the acid catalyst, hydronium. Okay, that's really it. Thanks for watching.